The purpose of the fuel system is to supply fuel to the engines and APU. The 787 has 3 fuel tanks: the center tank, the left main tank, and the right main tank. The center tank is capable of holding 22,200 gallons of fuel, while the right and left main tanks are capable of holding 5,600 gallons of fuel respectively. Altogether, the system holds a total of 33,400 gallons, or 223,700 pounds of fuel. This allows the aircraft to have a range of just over 7,500 nautical miles when in its Dash 9 configuration. This is almost twice as much of a 737 MAX 7. The aircraft also has 2 surge tanks located at the end of each wingtip. Surge tanks help ensure that engines are supplied with adequate fuel under all load applications by relieving pressure from fuel expansion from altitude and temperature changes and draining excess fuel back into the center tank. There are 7 pumps total throughout the system: 2 pumps in the right main tank, 2 pumps in the center tank, and 3 pumps in the left main tank. The additional fuel pump in the left main tank is a DC-powered pump that supplies fuel to the APU. This pump is there to supply fuel to the APU when AC power is not available and the APU selector is on. It has no controls or indicators other than the fuel synoptic display. The remaining 6 fuel pumps are all AC powered. The center tank contains a left and right fuel pump. These are override pumps that have higher output pressure than the forward and aft pumps located in the left and right main tanks. This is to ensure that during normal operation, the center tank depletes its fuel faster than the left and right main tanks. This is to ensure that minimum stress is exerted on the root of the wing during normal flight as the fuel burns off. All 6 pumps are designed so that a single pump may supply sufficient fuel to an engine under all operation conditions. The fuel manifolds are arranged so that any fuel tank pump can supply either engine. The crossfeed valve is closed during normal operations. The closed crossfeed valve isolates the left and right systems. The valve can be opened to feed an engine from the opposite fuel tank. Fuel can be transferred from main tank to main tank by using the fuel balancing system. Fuel transfer is initiated by pushing the fuel balance switch on. Fuel from the higher quantity main tank is transferred to the lower quantity main tank through the inboard jettison valves. Fuel can also be manually balanced by using the manual crossfeed valve. Manual crossfeed is initiated by opening the crossfeed valve and turning off the fuel pump switches for the fuel tank that has the lower quantity. Crossfeed may be done in all phases of flight. The fuel jettison system allows jettison from all fuel tanks. Fuel jettison is accomplished by opening the center tank jettison isolation valve and the main tank defuel valves. Fuel flows from the jettison manifold into the jettison nozzle overboard the ailerons. At least 8,700 pounds of fuel must remain in each main tank after jettison is complete. When main tank fuel pump pressure is low or a fuel pump failure, each engine can draw fuel from its corresponding main tank through a suction feed line.